Hey there, welcome to lesson 2 from our chapter 3, dealing with lines and angles and how their relationships are. Lesson 2 is going to talk about the angles when we have parallel lines. So unlike section 1, today we're going to have parallel lines. The same type of lines that we talked about in lesson 1 are going to transfer over to section 2. There's just one more step because there's a little bit more meaning behind if we have parallel lines. Remember the 4, we have corresponding angles, we have alternate interior angles, we have alternate exterior angles, and we have same side interior or consecutive. Couldn't think of the word. So those 4 are going to show up again in this lesson, but we're going to add one more thing to it. All right, so let's look at postulate 3.1, corresponding angles postulate. So it says if 2 lines are parallel and are cut by a transversal, so we have those 3 lines, then each of the corresponding angles are congruent. So corresponding angles are going to be congruent. Just as a reminder, corresponding angles are ones that lie on the same side of those parallel lines. So 1 and 3 would be congruent. 2 and 4, because they're corresponding, they would be congruent. 8 and 6. And then our last corresponding angle, 7 and 5. So because of our parallel lines, those little triangles tell me that this line is parallel to this line. Then I know that my corresponding angles are congruent. All right, we're not going to go through this proof, but I do want to look at the information they give us. So they give us that the measure of angle 11 is 51 degrees. And we want to find the measure of angle 15. So we're going to use the corresponding angles postulate to figure this one out. So we're looking at 15. So in your picture, notice that line X and line Y are parallel. So because they're parallel, then all of our corresponding angles are going to be congruent. So if the measure of angle 11 equals 51 degrees, and the measure of angle 11 is equal or congruent to the measure of angle 15 because they are corresponding angles, then I know that the measure of angle 15 also equals 51 degrees. All right, same picture, but let's bring it down here. I'm going to redraw that. I know that the measure of angle 11 fell right there. And then I'm going to look at 16. So 16 is right there. And I know that 15 was right there. All right, so it says I have measure of angle 11 is 51 degrees. I need to find the measure of angle 16. So sometimes these postulates won't be used directly, but we'll use them directly, and then it'll kind of help us get to the next level. So I know that because this angle is 51, then this angle would also be 51 degrees. And then the measure of angle 15 equals 51. And I know the measure of angle 15 is equal to the measure of angle 16 because of your vertical angles theorem, what we learned last chapter. So then I'm just going to substitute 51 right there. So the measure of angle 16 is going to equal 51 degrees also. All right, if you will stop this video and try your 2 check your progresses at the bottom of that page. All right, the measure of angle 22 would be 42. And the second one is also 42. All right, let's move on. So, again, we have these parallel lines that will allow us to have a little bit more information. So let's look at the other 3. So I have parallel lines right here. Notice those triangles. So your alternate interior angles theorem says if 2 parallel lines are cut by a transversal, then each pair of alternate interior angles are going to be congruent. So corresponding angles were congruent. Alternate interior. So 1 and 3 are alternate interior angles. I remember the alternate interiors, the alternate, I kind of jumped that line. All right, so alternate interior angles are congruent, and then let's jump down here to alternate exterior angles. If I have two parallel lines, excuse me, my alternate exterior angles are going to be congruent also. So I have 5 alternate. I'm going to cross that line. That would be 5 and 7, and then the 8 and 6 are going to be congruent also. All right, and then your consecutive interior angles are a little bit different. So let's look at those. Consecutive interiors are when you're on the same side of that line, of that transversal line. So if parallel lines cut the transversal, each pair of consecutive interior angles are going to be supplementary. So parallel lines, consecutive interior angles, supplementary, remember, 2 angles that add up to be 180 degrees. So I would have the measure of angle 1 plus the measure of angle 2 equals 180. I would also have the measure of angle 4 plus the measure of angle 3, because those are consecutive interior angles, are 180. All right, so just as a reminder, I'm going to put it off to the side. We have 3 angles, 3 sets of angles that come with congruence if they're parallel lines. So I have corresponding, I have alternate interior, and alternate exterior. Those 3 are going to be congruent. And then I have 1 that is going to be supplementary with your parallel lines. And those are going to be consecutive interiors. All right, let's look at some examples. All right, the diagram represents the floor of Michelle's house. I know that the measure of angle 2 right here is 125 degrees. I need to find the measure of angle 3, the measure of angle 1. So because they're tiles, I can assume that I want my tiles to be parallel. Now they give us some extra lines, so remember what we talked about. If you don't need it, go ahead and kind of scratch out what you don't need. It also looks like I probably don't need this one. So I'm going to look at these lines as being my parallel lines. All right, so if I look at just some pictures, this is kind of a puzzle piece, so maybe you'll find a different way to go about solving. I know that the measure of angle 1, because it is a linear pair with angle 2, I know that the measure of angle 1 is 180 minus 125. So 180 minus 125 will allow us to have your floor tile. All right, and then if you look at 2, and the other one I need to do is 3, 2 and 3, the measure of angle 2 and the measure of angle 3 are alternate interiors. So I know if 2 is 125, I also know that the measure of angle 3 is 125 because of your alternate interior angles theorem. All right, if you want to, go ahead and check your progress right below that. So your measure of angle 4 is going to be 55 degrees. I forgot to finish this one up here. That would be 55 degrees also. All right, let's keep on rocking. So we're going to use those theorems that you just learned and apply some algebra to some of these problems. So I have the measure of angle 5 right here, 2x minus 10, and then I have angle 7. And I need to find x. So you first want to identify what relationship do they have. Are they alternate interior, alternate exterior? So I like to highlight the two lines that they sit on, and then that transversal line. So I can kind of forget about all of this other stuff. I see that they're parallel, which allows me to use my theorems that we have talked about. So I see that these are corresponding angles. So that also means that those two angles are congruent. So the measure of angle 5 is equal to the measure of angle 7. So then I can just substitute 2x minus 10 is equal to x plus 15. Solve that. Add 10 to both sides. So I get that x equals 25. So I first need to identify what's the relationship. Then I either am going to set them up equal, or I'm going to set them up to equal 180, depending on if they are consecutive interior angles or not. All right, let's try this one. Again, let's see what they give us. Angle 4 is right here, and angle 8 is right here. All right, so I'm going to highlight, here's this line and my transversal line. So it doesn't look like they have any direct relationship. Right? But what if I move 4 down here, because those two are corresponding, and then I can see maybe 4 and 8 have a relationship of a linear pair. So I'm first going to talk with corresponding. Well, my pen wants to work. Plus linear pair. And I know that the measure of angle 4 plus the measure of angle 8 are going to equal 180 because of that linear pair. So notice I went from 4 and I put it down here. That would give you corresponding angles. Let me blow that up a little bit. 4 is there and 8 is here. So 4 can also go there because of corresponding angles. And then I can utilize this right here as a linear pair. So I'm just going to substitute 4 times y minus 25 plus 4y is equal to 180. I get 4y minus 100 plus 4y is equal to 180. I'm going to add. Don't forget to use your correct math skills. I'm going to combine like terms. 8y equals 280. Divide by 8. Y equals 35. Just make sure you know what they're asking you to find. Are they asking you to find y, or are they asking you to apply it back, or push it back in there? All right, and go ahead and do your algebra. Check your progress. They're asking you to find x, and your x is going to be 12. All right, and then the last one that we're going to talk about is just your perpendicular transversal theorem. It just says, in a plane, if a line is perpendicular to one of two parallel lines, then it is perpendicular to the other. So if I know that T is perpendicular to A, I also know that A and B are parallel. That would imply that T is perpendicular to B also. All right, and then just a little reminder, if you have parallel lines, here are the relationships that give you a little bit extra to solve some more problems. All right, that's a wrap for section 2. We'll see you next time.